Hello dear students, welcome back to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So yes, today like we are, as you all know, we have done with the PU2 syllabus and we have started this PYQ series. So today we will be discussing the top 30 PYQs compiled from last 10 years, that is from 2014 to 2024, of the most important chapter, that is Haloalkanes and Haloarenes. Okay, so we'll be doing a lot of PYQs. I'll be telling you like what is the, so that you can understand that from this particular chapter what is that level of question that is asked, what type of questions are being asked, you can understand. Okay, so please sit with a notebook and a pen and then try to solve these questions with me. First pause the question, solve it, and then check the answer. Okay, so yes, now let's get started. One more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. Now if you join our WhatsApp channel, you will get access to all this PDF notes, mock test, PDF solutions, PDF, everything is available in our WhatsApp channel. So please do not forget to join the WhatsApp channel. Okay, it will be beneficial for you. So now let's get started with the first question here. So the first question is the correct IUPAC name of. So this question was asked in 2021. Okay, the question was very moderate, I'll tell, because you should see the options are very confusing. So you should know how to number the substituents. If you know that very well, then this question will not take more than 15 seconds. Okay, so now if you see here, we'll first see the substituents. Okay, 4, 1 and 2. What does the substituent rule says? That the sum of the positions of the substituents should be less. Okay, sum of the positions of the substituent should be less. This is a rule that you must remember. Now if I see in the first option 4, 5, 6, 7, the sum of the substituents, if I add, it is 7. Now if you see here, it is 4, 3, 1, 4, 3, 7, 8, this is 8. Here if you see 6 and 3 and 1, right, 6, 3, nitrobenzene is taken as 1, so that is why that is not mentioned. So 6 plus 3, 9 plus 1, 10. And now if you see here 5, 6, 7, and here also nitro is not mentioned, that means it is position number 1. So 5, 2, 1, that is 8. Okay, so according to the rule, the lowest substituent sum should be the correct one. So you can see the option number A is having the lowest sum, so that is why option number A will be the correct answer. Okay, fine. Now let us see the next question. So this question is from physical properties. A pair of compounds having the same boiling point are. So question was asked very recently in 2023. So you should know here that the enantiomers, okay, enantiomers have same physical properties and different chemical properties, right? But there is one physical property which is different for the enantiomers as well. Okay, there is one physical property which is different for enantiomers as well. Please comment down which physical property is different. All other physical properties are same for two enantiomers, but there is one physical property which is different, so that you need to comment down. Okay, so now if you see so boiling point is a physical property, right? So that means enantiomers will have the same physical properties or same boiling point. Cis and trans will have different. These are two different compounds, they will have different. Benzene, naphthalene different. If you see here, plus minus butane 2OL, these are enantiomers, plus minus, so that is why they will have same physical properties. Option number D will be the correct answer. Fine. Next question, which of the following statements is true in case of alkyl halides? So this question was asked in 2018. Very easy question if you just have general idea about the physical properties of alkyl halides. So the first thing is they are polar in nature. So if we see CH3Cl, okay, chlorine being more electronegative has delta minus and carbon has delta plus charge. Okay, so now because there is charge separation, they are polar in nature, so option number A is the correct answer. They can form hydrogen bonds. No, there is no way how they can form the hydrogen bond. This is incorrect because they are not able to form hydrogen bonds. They are not highly soluble in water. They undergo addition reactions. Addition reactions are undergone by double bonds. Wherever we have double bonds, there we can see addition reaction. Here there is no double bond, no addition reaction. This is also incorrect. So correct statement is option number A. Okay. Now next question. The arrangement of the following compounds in the increasing order of their boiling points. So this question was asked in 2015. Again a super easy question if you have general knowledge about, like general knowledge means the basic idea about what the boiling point is dependent on. Okay. So if you remember here, okay, boiling points depends on mass and inversely proportional to branching. Okay. If the mass is more, boiling point will be more. If the branching is more, then boiling point will be less. Now if you see here, we have dibromomethane, chloromethane, bromoform and bromomethane. So first let us write down the structures of them so that we can more easily compare them. Now bromomethane is CH3Br, bromoform is CHBr3, chloromethane is CH3Cl, dibromomethane is CH2Br2. Okay. So now if you see here the first one, okay, here we have maximum number of bromine. So definitely its mass will be the highest. So 2 will be highest, right? So we can eliminate these two options. Now after that you see here we have 2 bromines, right? So after 2 it will be 4. So after 2 here it is 1. So we can eliminate this one. Correct answer will be option number C. Okay. So 3 because it is chlorine, it will be the least, then 1 bromine, 2 bromine and then 3 bromine. Okay. Next question. The question is from the chemical reactions. From maximum or majority of the questions you can expect from the chemical reactions part, and especially for SN1 and SN2 mechanism. Okay. So here question number 5, in which of the following pairs of halogen compounds undergoes faster SN1 reaction? Okay, question was asked in 2022. Super easy question if the mechanism, if the concept of SN1 reactions are very clear to you. Okay, so for SN1 you need to remember the order, that is 3 degree, 2 degree and 1 degree. Okay, so now if we see the structure, in the first one this is 3 degree and this is 2 degree, right? So obviously this one will be the winner. 3 degree you can see in first one, here it is taken different one, this cannot be the answer, this cannot be the answer. Out of these two any one will be the answer. Now here if you see this is 2 degree and this is 1 degree, so out of these two obviously this one will be the winner. So here we have both the correct options. So the correct answer for this question will be option number D. Okay. Now next question, which one of the following chlorohydrocarbon readily undergoes solvolysis? So question was asked in 2022. This question is easy, but I have kept it moderate because if you do not the mechanism of solvolysis, or it depends on which what is the mechanism of solvolysis, if that is not clear to you, then this question will be difficult. So remember solvolysis always, so remember one point, solvolysis involves cation formation. Okay, in solvolysis there is always formation of cation. Okay, so wherever the cation is more stable, there the reaction will be faster. Okay, if cation, so what I can say, stable carbocation, if the carbocation is stable, then we will have faster reaction. Okay, and what is the order of stability of carbocation? Order of stability of carbocation, first is your benzyl carbocation. Okay, next we have 3 degree, then 2 degree and then 1 degree. Okay, so now if I see here, so how to first how to find out the carbocation? So to find out the carbocation you should remove the X, remove X, then you will get carbocation, then you need to check the stability of the carbocation. Okay, so if I see now here after this chlorine goes, plus charge will come on this carbon, right? Now here if it is goes, this is plus 1 will come here, if this goes, plus will come here and plus will come here. Now carbocations on the sp2 carbons are highly unstable, okay? So what I am saying here, carbocation on sp2 carbon are unstable, right? So here you can see we are getting carbocation on the sp2 carbon, here also we are getting the carbocation on the sp2 carbon. So both these options are not correct, okay? These both the options are incorrect. Now if you see here if you see, this is we have a benzyl carbocation and here you will get primary carbocation, right? This is primary and this is benzyl carbocation. Now benzyl carbocation obviously will be more stable, so that is why this is correct answer. Why benzyl carbocations are more stable? Due to resonance, okay? Fine. Let us see the next question. Identify the products A and B in the reaction. Question was asked again in 2022. This question is also easy. You should not get confused with the reagents. Then this question is very easy. So if you remember KCN, okay, adds Cn or substitutes Cn in place of X. So that is why B will be RCN. Okay, so RCN, we can eliminate this option. And AgCN adds NC group, that is isocyanide group. Here NC, here Cn, so we can eliminate this one. Option number A will be the correct answer. Okay. Next question. Br2 UV light, okay. So this is following free radical mechanism. So most stable radical will give you the bromine, right? So here we can get so this question was asked in 2021, okay. This is also very easy question, just you need to be little bit careful about the radical formation, right? So we will get this H can be replaced or this H can also be replaced, right? So this H, if here we get a radical, okay, that will be more stable because it is resonance stabilized. So what will happen? This H will be replaced with bromine. So you can see here this is wrong. You students might select option number A here, that is wrong. Here this is option number B is correct. This one is completely wrong because bromine, to attach bromine in the benzene ring, we need the reagent Br2 FeBr3. UV light will not add bromine to the benzene ring, okay, and the same thing here. So correct answer is option number B. Fine. Next question, the order of reactivity of the compounds, okay. So reactivity of the compounds, haloalkanes compounds are given and we need to find their reactivity order. 2021 question, again a simple question, you just need to check about the stability of carbocation, okay. Fine. So now if I draw these structures, okay, so we have 1, 2, 3 and 4 structure, okay. One second. Okay, so let us see the first structure. We have C6H5CH2Br. So I am drawing small structures here. This is the first one, okay. Fine. Next we have C6H5CH, C6H5Br. So it is like this, C6H5, C, C6H5, H and Br, okay. Next we have C6H5. So this is the next one, C6H5, C, H, Br and then CH3. Next we have C6H5, CCH3, okay. So next compound is like this, C6H5, okay. Then I have CCH3, then we have C6H5 and we have Br, okay. So we have to remove this Br to get the carbocations, right? So what we can do is we'll remove this Br and at that position we will get the carbocations, okay. So here we'll get a carbocation, this carbocation and then this carbocation. Now if you see here in this particular group, there are 2 phenyl groups which is stabilizing this carbocation due to resonance and CH3 is also stabilizing due to plus I effect. So that is why this carbocation will be most stable. So that is what, which option? That is present in option number C. Okay, what else we can see? Here also it is present, here also it is present, here it is not present, so we can eliminate option number A. 2C6H5 and 1CH3, 2C6H5, 1CH3, 2C6H5, 1CH3, these three options are having the same one, right? Now after that, if you see here, here we have 2C6H5 groups, right? That is more stable because it is stabilizing due to resonance. So we need, next one is 2C6H5 group, it is present here, here also that is present, here this is not present, right? So we can eliminate option number D. Now after getting 2C6H5, I need like out of these two, we'll have one phenyl ring and one methyl ring. So here it is phenyl ring and H groups are present, whereas here it is phenyl group and methyl group. So that is why option number B will be the correct answer here. Okay. Next question, the major product in the following reaction. Okay. So now if you see, this question was asked in 2021. Okay, very easy reaction based question. Just you need to be careful here about the excess reagent. Okay, that is why this question can also come in moderate, because many of you might skip what happens if HBr is present in excess. Okay, so first of all, what will happen? HBr will be added to the ring following Markovnikov's rule, right? So Br will be attached here and H will be attached here. Now again, if you add HBr in excess, so what will happen? This OH will get protonated to give you O plus H2, okay, and after that Br minus is there, Br minus attacks on this one, O plus H2 goes out, so we will get here Br, okay. So here what will be forming? Here we will be getting Br, okay. So 1, 2, 3, we will get excess of 2 Br positions will get. So correct answer is option number A. Many of you might write option C as the correct answer, okay, because you will just add HBr following the Markovnikov's rule, but might, you should remember here that it is given in excess. So this OH will also react, okay, fine. Next question, which of the following halide shows highest reactivity towards SN1 mechanism? So again 2020 question, basic easy question. If you know the order, then it is not more than 15 seconds question. So again it depends on the stability of the carbocation, right? SN1 reaction depends on the stability of carbocation, right? So here what I'll get? A primary carbocation. Here also I'll get primary carbocation. Here this carbocation is a carbon on sp2 carbon, and here I'll get benzyl carbocation. So that is why this is more stable. Option number D will be the correct answer. Next question, in the reaction, this one is Grignard reagent and CH3NH2. The dry ether gives you. So for this question was asked in 2020. Okay, this is easy to again moderate question if you know this reaction. Okay, so you should know that we have RMgX. One second. Yeah, so if you have RMgX, okay, and you have RNH2, so this will give you RH. Okay, so just one H will be added here. So what will be the product here? We will get like this, right? This is the product CH3, CH3, CH3 and CH. Okay, now we can have a linear chain of this one also like this, right? So total 2 isomers will be possible. So this is your compound X, it can have another isomer of this one, so that is why correct answer will be option number C. Okay. Next question, which of the following halides undergo hydrolysis on warming with water aqueous NaOH? Okay, question was asked in 2019, easy question. Haloarene reactions you should know that haloarenes see do not undergo nucleophilic substitution reactions, but if the haloarene is electron deficient, if it is electron deficient, then it can undergo nucleophilic substitution reaction. Okay, so reaction with NaOH means adding of OH group is nothing but a nucleophilic substitution reaction. Okay, so for nucleophilic substitution reaction we need electron deficient haloarenes. For electron deficient haloarenes I need electron, more and more electron withdrawing groups are needed, right? I need more electron withdrawing groups. So if you see, yeah, here we have 2 electron withdrawing groups, here we have 1 electron withdrawing groups, and here we have 3 electron withdrawing groups. So this ring will be least like more electron deficient, so the attack of nucleophile will be easier here. Okay, so correct answer will be option number D. Okay. Next question, the compounds having the longest CCl bond. So if we want longest CCl bond, that means question was asked in 2019, again a super easy question. If you want longest CCl bond, then this bond should be purely a pure single bond. Okay, it should be a pure single bond. Now if you see here, there is resonance, right? That is why this bond is not a, it has a partial double bond character. Now if you see here, this is a pure single bond. Here also we have resonance, so this is partial double bond. Here also we have resonance, this is partial double bond. So correct answer will be option number B. Okay. Next question, tertiary alkyl halide. Okay, tertiary alkyl halide is practically inert to substitution by SN2 mechanism because of. So this question was again asked in 2018. Super easy question, very simple question. Why SN2 reactions do not, or tertiary alcohols or tertiary halides do not favor SN2 reaction? Because SN2 reaction is a reaction where we need less steric hindrance, and tertiary alcohols or halides have more steric hindrance. That is why they do not react by SN2 mechanism. Okay, so the reason here is steric hindrance, option number D. Okay. Next question, the reactivity order of halides for dehydrohalogenation is. Question was asked in 2016. This is a easy question. You should be knowing how the dehydrohalogenation takes place. So here you should know one thing, that in case of dehydrohalogenation, okay, so we have like this CH2, suppose H, CH2, Cl. Okay, so first this bond breaks. Okay, first this bond breaks to give you what we have, CH2, H, then CH2 plus. Okay, next this bond comes here and a double bond is formed here. So first step is what, breaking of this bond. So it depends that in which case this bond can break easily. Okay, so if we have iodine here, this bond will be the weakest. Now why this is happening? Because of poor overlapping. Okay, size difference is there. Carbon is a small atom, iodine is a very big atom, so there is poor overlapping of orbitals, so bond is very weak. So iodine can break easily. Okay, faster can happen in iodine. So that is why we need iodine. This will be wrong. After iodine it is bromine, then chlorine, then fluorine. So option number B. Okay. Now next question, the hydrolysis of optically active 2-bromobutane with aqueous NaOH results in the formation of. So 2-bromobutane, if I draw the structure, so question was asked in 2015, so you should know about the stereoisomerism of SN1 and SN2 reaction. Now 2-bromobutane, that means I have like this. Okay, this is 2-bromobutane. Now if you see, this is what optically active compound. Okay, so we will get a plus minus of this one, both the isomers will form, so we will get, and OH will come in this position, right? So this one we will get plus minus butane 2OL. Okay, that is your option number B. You know here which mechanism will be followed, SN1 mechanism will be followed. Okay, so that is why we will get plus minus butane 2OL. Okay. Yeah, next question number 18. An incorrect statement with respect to SN1 and SN2. So again 2014 question, you should know about SN1, SN2, basic things. Okay, so a strong nucleophile in aprotic solvent increases the rate or favors the SN2 reaction. So it is saying SN2 reaction is favored by aprotic solvent. Yes, that is correct. And we know SN1 is favored by protic solvent. right? These two statements, this is the thing. Competing reaction for an SN2 reaction is rearrangement. Now see, in SN2 reaction there is no rearrangement possible because there is no carbocation formation. There is direct a formation of transition state and then we get products, right? So there is no chance that we can have a competition with the rearrangement reaction. So that is why this statement is incorrect, option number B. Okay. Next one, if you see SN1 reactions can be catalyzed by Lewis acids, yes, that is correct here. A weak nucleophile and a protic solvent increases the rate of SN1 reaction, that is also correct. Okay. Next question is about again reaction based question, 2015, easy question if you know the reactions here. So first of all we have first we'll get the Grignard reagent, right? So A will be this one. Okay, so this is A. Now after that what will happen? This is plus, this is minus. H2O is there. H2O has H plus and OH minus, so H will attack here. Okay, so we will get like this. Okay, and OH will attack on this one and this one will go. So this is nothing but cyclohexane. Option number D will be the correct answer. Okay. Next question, which of the following compounds would undergo elimination reaction more easily? Okay, elimination reaction. So for elimination reaction, okay, you should know the concept of again carbocation stability. Okay, carbocation stability should be there. So now if I see that, yeah, here if there is elimination, okay, here if I get elimination I will get a tertiary carbocation. If this bromine goes out, here I will get a primary one. So definitely primary one cannot be the answer. Here also I will get a primary one, cannot be answer. But yeah, here also I will get a tertiary, right? Now if both are giving you tertiary, the first step is what? This breaking of Br and Ci. Just now we discussed that Ci bond is very weak, it can break easily, right? So that is why this one will be have the fastest reaction, option number D. Okay. Next, 1-phenyl 2-chloropropane on heating with alcoholic KOH gives mainly. So this reaction again from your elimination reaction. So you can be confused here with the reagents. What reagents can be there? Alcoholic KOH and aqueous KOH. Okay. So remember, alcoholic KOH gives you elimination, okay, and aqueous KOH gives you substitution. Okay, these two things you should remember. Now let us do 1-phenyl 2-chloropropane. So we have 1-phenyl, okay, and then I am drawing like this, 2-chloropropane, right? So what will happen? Here there will be dehydrohalogenation and we will get a double bond here. Okay. So now what I will get? I will get here, we will form alkene, right? So these all will be wrong. We will get 1-phenyl propene, that is option number A. Okay. Next, which is the most reactive for SN2 reaction? So again this question is also based on SN1 and SN2 mechanism. You should know the order of SN2 mechanism, that is 1 degree, then we have 2 degree and then we have 3 degree. And it should be less steric hindrance. Here there will be less steric hindrance because it is a small molecule. So correct answer will be option number A here. Okay. Next, the combination of which produces a tert-butyl alcohol when treated with Grignard reagent. Okay, so if you see the first option, okay, here what will happen? CH3, CO and CH3, okay, and we have Grignard reagent of CH3 MgBr, right? So minus plus, this is minus, this one will attack here and this bond will shift here. So what will I get here? I will get CH3 COH, means OMgBr first I will get, then I have a CH3 and then another CH3. Now this OMgBr gets changed to OH. Okay, so I'll get tert-butyl alcohol. So the correct answer here will be option number A. Okay. Next question, the reaction between chloroethane and potassium hydroxide is a dash order reaction. This is an important question. Chloroethane, means you have chloroethane, okay, and potassium hydroxide. Okay, so what will happen? This one will give you CH3 CH2OH, right? Now this is a primary haloalkane, right? Primary group. Okay, now if it is a primary group, which reaction it will follow? SN2 mechanism will follow, right? And in SN2 mechanism, you know it is a second order reaction, right? So that is why the correct answer for this question will be option number C. Okay, next reaction based question. Okay, let us see. First of all, you have alcoholic KOH. So alcoholic KOH is like, first it will be having dehydrohalogenation, right? So I will get CH3 double bond, sorry, CH2 CH2. Okay, so we will get first, this is your X. Now if I add bromine, then what will happen? If I add bromine, I will get CH2Br and CH2Br. Okay, after that if you give Cn, that means what will happen? Both will be converted to CnCn. So correct answer will be option number B here. Okay, fine. Next question. A haloalkane undergoes SN1 and SN2 reaction depending on. So this question was asked in 2024. Again a simple question, you just need to know about the mechanism of SN1 and SN2. So SN2 reaction depends on solvent used in the reaction. So you should know that you should have a aprotic solvent. Okay, so correct answer will be option number A. Next, 2-methyl propane can be prepared by Wurtz reaction. The haloalkanes taken along with metallic sodium and dry ether are. 2024 question, Wurtz reaction, very simple question. You need to prepare 2-methyl propane, right? 2-methyl propane. So you need to take one haloalkane like this and one haloalkane like this, right? So you need to take chloromethane and 2-chloropropane. So if you take chloromethane and 2-chloropropane, we will get this compound, right? So correct answer will be option number A. Let us see the products for all the reactions. Once again, we'll see option wise option. Okay, once again. Okay, let us first see option number B. You have chloroethane and chloropropane. So you have chloroethane and I'm just writing like this, chloropropane. So what will happen? This chlorine will go and these two will join. So I will get here pentane. So product of option number B will be pentane, which is not the required product. Next, chloroethane and 1-chloropropane. So the same thing, I think, chloroethane and 1-chloropropane, same product we will get here. Next, chloromethane and 1-chloropropane. You have chloromethane and 1-chloropropane. Again this one will go and we will get a butane as the major product, right? So that is also not the required product. Now you can see the question, chloromethane. You have chloromethane and you have 2-chloropropane. You have 2-chloropropane. This one will go, this two will join, and that is what is required here. Okay. Next question number 28. In the following scheme of reaction, you just need to identify the reagents correctly. Okay, easy question if you have learned the reagents correctly. So for this one, fluoroalkanes, you know, this is Wurtz reaction. We need metallic fluorides. So AgF, Hg2F2 will work. HF will not work. Option number B we can eliminate. Okay. Next you have Y. You can see alkene is formed, so we need alcoholic KOH. So alcoholic KOH, alcoholic KOH. Here aqueous COH, we can eliminate this one. Next we see, you see the number of carbon has doubled, that is Wurtz reaction. We need sodium and dry ether. Okay, so correct answer for this question will be option number C. Okay, this is not the correct one. Fine. Next we have polyhalogen compounds topic, some questions. So prolonged exposure of chloroform in humans may cause damage to liver. It is due to the formation of following compounds. So 2020 question. So chloroform reaction produces a harmful compound, that is phosgene, COCl2. That will be the answer, option number A here. Next, the antiseptic character of iodoform is due to, so this is due to the liberation of free iodine, that is option number C. Okay, so yes students, so these were the top 30 questions from the previous year. So there were not 30 questions from the previous year, so I have added some questions from extra like comment case, some previous year questions I have added. So I hope this video was helpful. You would have revised the concepts, and you should remember now that the similar questions you can expect in your KCET 25 examination as well. So when you are preparing, revising, so please focus on SN1 and SN2 mechanism. You see, most of the questions were based on SN1 and SN2. Okay, so try to practice more questions from these topics. Okay, so yes, that's all in this video. Thank you for watching, and please do not forget to subscribe the channel, and remember your target 60 out of 60 in KCET chemistry. Okay, see you soon in the next class.